Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we are discussing the energy spreading and delamination of composite material for ballistic application, textile based composite. So, mechanisms we have discussed. So, delamination and role of weave structure, so how the fabric construction facilitate the energy transfer. Now, the mechanism of energy dissipation is by friction. So, friction which generates heat and which friction against the projectile and the composite and also between the fibers, and which helps in dissipating the kinetic energy. So, multi-layered structure system also we have discussed in last session, and significant contribution to woven and unidirectional fabrics. Now, we will discuss the fiber fracture and yarn pull out. Basically, when the projectile hits on a fabric, the fibers take load first or yarn, and then what happens, suppose this is the textile structure or composite structure. In a case of say any bullet hit, so it will try to apply load vertically, and the fibers or yarns coming in this in its way will be stretched, and then the yarn on the other side, yarn will be pushed on the other side. This is called yarn pull out test, and depend if the fibers or yarn frictions are high, then it will resist this yarn pull out. The basic mechanism here that at the extreme load, when the extreme load is there, fiber and yarn may break. So, which will absorb the energy, that the fiber or yarn before it breaks, it will absorb the energy depending on its work of rupture. So, that is a fiber fracture, and in case there is no breakage, there is a slippage, that means that yarn will be pulled out. So, in case of yarn sliding, so it will slide out the weave, and which will contribute to the energy absorption. So, during the yarn pull also, that when the yarn is sliding out, it will also absorb the energy. So, there are different ways of energy absorption. So, we have to have some balance, like desirable behavior we need, and what are the material limits. So, that balance we have to do, because we have to select certain material depending on our need. So, what type of behavior we need. So, if we need that this yarn pull out should be there, the absorption should be by the yarn pull out, then we can select particular yarn or fabric or fiber. If we want that it should not slide, but it should absorb the energy by fracture. So, different processes are there. So, we have to select our fiber, yarn or fabric structure accordingly. So, basically the high performance fibers are it is a foundation of protection. So, for any protection, ballistic protection, we need high performance fibers. Cornerstone of modern ballistic protection lies in advanced polymer fibers. That is the most important part. So, if we do not use the advanced polymeric fiber, normal fiber, we cannot have the ballistic protection. And after this polymeric fiber is generated, then we have to engineer the structure. So, we have to meticulously engineer the structure for extreme conditions. So, that we have to take into account. So, one is the polymeric fiber, advanced polymeric fiber we have to use, then we have to design the structure. So, these materials are designed to arrest high velocity projectiles and then distribute the impact within the wider range, and these two things are basically done by combination of advanced polymeric fiber and the proper designing of the structure, textile structure. So, high tensile strength is a first basic requirement of any ballistic protection. So, for high resistance, what we achieve? It will have ability to withstand significant pulling force before it breaks, which is crucial for energy absorption. So, high strength is very important. Then high modulus, because even there is a high strength, if modulus is low. Now, let me draw two fibers. A and B. Both A, this is the strain, stress. Both the fibers have say same breaking stress. Which one has to be used? B has got higher modulus and A has lower modulus, because it will deform with a lower stress. So, if we use high modulus B fiber, so it will resist to the deformation under stress, ensuring the structural integrity. So, structure will not get deformed, okay. But at the same time we have to see the energy absorption capability. We cannot have very brittle fiber like this type of say C with very low energy for rupture. So, high tensile strength is important, high modulus is also important, then low density is also important, because the material has to be light. It should not actually impose additional burden on the user. So, exceptional strength to weight ratio has to be there, which is vital for reducing the burden on the personnel who is actually using. Then energy absorption capability. So, it is the capability to dissipate the impact energy efficiently, and as we dissipate the energy, it will prevent the perforation, okay, and minimizing the trauma. So, that is the basic idea of energy absorption. So, high performance fibers with high tensile strength, high modulus, low density and high energy absorption are the critical requirement for the ballistic protection. Now onward we will discuss the protective, we will try to understand the protective clothing in general. Till now what we have discussed, the basic concept of ballistic protection, the standards, different types of mechanisms we have discussed. Now we will try to concentrate on ballistic protective clothing. Okay. Now, the basic requirement here is the impact resistance in any ballistic protection. So, we need impact resistance. So, ability to withstand the failure due to stress applied at high rate, that is the impact. When the stress is applied at high rate, that material has to withstand. So, that is the impact resistance. A material can have very high strength, but if it cannot withstand the force or withstand the failure due to the high stress rate, so then that material will not be useful for ballistic protection. So, the important properties which are there in textile materials are there. So, here the textile materials, these properties are, most of the high performance textile fibers have these properties. They can withstand the stress at high rate. So, where like body armor, mountaineering rope, parachute. So, where at high rate the stresses are applied along with the body armor. So, there are many other applications where we apply the load stress at very high rate. So, in all these applications textile materials are used. Now, before we go further understanding the ballistic protective clothing, let us first try to understand some common threats. Our basic here, that you can see there mortars are there, some ancillaries are there, different artilleries, like these are the different types of, like guns are there, rocket, the different types of threats are there. Now, the projectile impact, if you see the projectile impact in normally in our study, we have seen that during the standard the direction of the impact should be exactly vertical with plus minus 5° deviation is there, where penetration will be 100%, because impact will be 100%. But if the impact is at certain angle, that means that in that case penetration will be less and the impact force will also be low. Now, there are different types of garments available and there are different types of armors used that these garments are manufactured based on the types and levels of the threads caused by the projectile. So, different types of garments are there. So, the threads are classified into different types of categories based on the kinetic energy density which is called KED. So, different types of kinetic energy density which is the energy per unit area joule per square millimeter. So, for knife the velocity of knife it is 10 meter per second and the kinetic energy density for blunt knife it is 17 and for sharp knife it is 210. So, for knife you see the kinetic energy density is very high then. Although the velocity is low, here velocity is low, but kinetic energy density is very high, particularly for sharp knife. So, there the material we need special material due to the very high kinetic energy. So, special textile or plates we have to use due to the sharp edge it will penetrate. So, we have to protect ourselves, but this thread it is not, we cannot call it as it is a different types of thread, it is a knife thread, although it is a ballistic protection garment is required. Now, handgun if we see the velocity is very high, 45 times higher than the knife, but the kinetic energy density is very low, like 16 is initially and finally it becomes 4, and that is mainly due to the in handgun the cartridge we use is basically it is a blunt one with a very higher area, cross sectional area, that is why the kinetic energy density is there. So, here we use the textile multi-layer textile material we can or special textile structure we can use. Assault rifle like it is like AK-47 assault rifle bullets where the velocity is very high 720 meter per second and kinetic energy density is 45, okay, and we can use the composite textile based composite, and high velocity bullets say SA-80 type of bullet velocity is very high 940 meters per second and kinetic energy density is 75 where we use the ceramic. So, for high velocity bullet we use the ceramic material. So, the bulletproof vest which actually consists of textile material. So, the bulletproof vest is a protective clothing that can be made from different material which absorbs the impact of the projectile fired from the weapon and or explosive fragments fired at the body. So, maybe any bullet, any type of projectile. So, and maybe bullet, maybe any fragment. So, it can be prepared from steel, titanium, ceramic, polyethylene, high performance polyethylene, or maybe aramid. So, different types of fibers or different types of materials can be used. So, steel, titanium, ceramic we can use for hard body armor. So, but bulletproof vest do not deflect the bullet like steel or hard armor. So, if we see the soft bullet, so it does not deflect the bullet, but it absorbs the bullet. So, instead it catches the bullet, okay, and spread its force over larger portion of the body. So, the back face signature. So, back face trauma is reduced. This mechanism we have already discussed. Now, these are the different types of ballistic protective equipments. Now, first let us try to understand the different countries, what are the different types of body armors they use. Like in Australia, this is basically in general, but their structural difference will be there to some extent, and British Australia TBAs. So, in British it is ECBA, okay. Another, this is a Canadian one, Chinese EBA, Danish, Russian, US, okay. Different types of bullet proof vests are there, but these are the some examples just to give idea. But different countries, they have different types of bulletproof vest they use depending on the threat perception. First, now let us try to understand how the body armors evolved. So, throughout the history, people have protected themselves from injury with different types of materials. So, they have protected themselves. So, in early ages, in say in the stone age, people used to use animal skins as barrier to protect them from injury and attack. So, animal skins they used to use. And with the development, as the human becomes more civilized, so with the civilization, the weaponry are becoming more advanced. So, threat perception, threats are becoming more severe. So, that is why we have to develop our protective clothing in a different way. So, the next generation body armor was that wooden shield to defeat the different types of threats. After that, the wooden shields people used to use, okay, for protecting themselves. In the year 1500s, the century, the Russian and Roman royalties experimented with the idea of bulletproof vest. That time it started, the bulletproof vest, where people will wear some protective vest. this is the type of vest shield they try to use. This is the soldier shoulder plate, so wooden tunic, different types of combinations are there here, metallic plates are there. So, the built the body armor with layers of metal, those were meant for deflecting the bullets. So, that was the idea. Here different types of metals used. So, that was actually the main idea initially, to deflect the bullet from penetrating. That was the first idea there. So, the outer layer were designed to absorb the bullet impact with the hard liner, while the inner layer are added to stop the penetration. So, there are different layers used. However, the metal body armor was largely ineffective due to the heavy weight. So, it is ineffective due to the against the firearm, and because of the weight, and it restricts the body movement. Ergonomics were poor ergonomic design. So, as we are becoming more civilized, the threats are becoming more severe. So, with the time, so therefore, challenges lie developing the materials that will provide higher impact resistance. So, metal, wood were there, human animal skins were there, but that was not serving the basic purposes with their obvious drawbacks. So, then the main challenges were to developing a material that will provide high impact resistance while maintaining the weight of the assembly at an acceptable limit. So, lower weight, high impact resistance, that was the basic idea to develop the next generation material. So, the materials were developed, and which were body armors were developed mainly in two areas, two types that we have already mentioned. One is the hard body armor, then soft body armor. Now, hard body armors, here the metal or ceramic plates are inserted within the fabric structure. So, here metals or ceramics are inserted, which will be actually useful for high threat. So, they are rigid, they are heavy. This is used for military officer with a high risk zone. At the high risk zone, it will protect from the high velocity projectile. The main disadvantages are that it is a hard and heavy weight, restrict the body part movement, and on the other hand, soft body armor is multi-layered woven or laminated fabric structures are there, more flexible in nature as compared to hard body armor. It is a lighter weight, used for routine wear for police officer and security person. For routine work it can be used. So, low velocity projectile threat it can protect against the low velocity threat. A main disadvantage is that it is you require 20 to 30 layers are required for sufficient protection. So, again it becomes inflexible in nature and also heavy. So, we are using suppose in the 20 to 30 layers of cloth to make the soft body armor, then it becomes the inflexible, rigid. So, that is a disadvantage, and it can only be used for low velocity impact. So, this soft body armor, although it is a lighter in weight if we see, but here the only it is used for low velocity impact. But if we can develop cloth material with the advent of the new materials, that we can actually use that soft body armors should also be used for high velocity impact. So, impact resistance here, it depends on the type of fibers used, and also what are the type of yarns we use and the fabric structure. So, we can manipulate the impact resistance characteristics by selecting proper fiber, proper yarn structure and fabric structure. So, that is why generally multi-layered woven fabric structures are used for body armor. So, this structure is heavy, thick, inflexible, so uncomfortable is there. Multi-layer when we are using, they become inflexible. Now, if you see the comparison, hard body armor, they are rigid, heavy, fabric structure is combined with the steel or ceramic plate insertion used for military operation with high risk zone and protection against the high velocity projectile. Whereas, in soft body armor, they are more flexible, lighter in weight, multi-layer woven or laminated fabric structures are used for routine police officers or security personnel, and it will protect us from the low velocity projectiles. So, the requirements are for any good ballistic protective textiles. So, better impact resistance, it should be weight reduction should be there, and flexibility improvement. So, these are the basic requirement for any future fiber development for this. So, it should be lighter, better energy dissipation, it should absorb more energy and dissipate, and it should be flexible. So, depending on this requirements, the future ballistic materials are actually developed, and the research is towards in those directions. So, you can see the soft body armors, the main advantage here is that, so aerial density, the mass is reduced over the time. So, you can see here the kg per square meter, the mass were initially you can see here it is a very high. With the time we can actually you can see that the research was going on for same bullet 7.62 armor piercing bullet AP bullet. This the same in 1980s we used to use the steel with typically around 160 aerial density kg per square meter. So, we can see the and for 1 square centimeter So, 160 kg was used, that type of steel plates, heavy steel plate was used. So, which is nowadays it is that time it would have been very difficult, but with the time this is reduced by introduction of ceramic and polymeric composites. So, it has reduced to 35 kg per square meter in 2010. Now, the further it has been reduced to a greater extent with the advent of the latest fiber. So, still this research are going on. So, cartridge specification we have already mentioned few. Here you can see that M14 rifle, the cartridge is 7.62 by 51 millimeter, that length is there, this is the diameter, and the mass is 393 grains, typically around 25.5 gram, and the weight of the loaded magazine is 0.68 kg for 20 rounds. Okay. So, these are the different types of for M16, for AK-47. So, different types of cartridge weights are there. So, these are the overall idea of cartridge specifications. These are the different dimensions. You can see this is the bullet dimension, we are not going into detailed. So, the velocity comparison between this 7.62 by 51 mm NATO, 0.3006 Springfield and 0.300 W&M Winchester and Magnum for common bullet weight. So, these are for velocity, these are the different types of bullets. Now, there you can see the velocity comparison. So, bullet weights are there and muzzle velocity. You can see this is a NATO, we will have for a certain bullet weight, for a particular bullet weight, it is available in 3 different bullet weights, 150 grain, say 165 grain and 180 grain. So, with the increase in this bullet weight, the velocity, so muzzle velocity in feet per second, it reduces for all the type of bullets. With the increase in this mass of the bullet, the muzzle velocity will reduce. But in case of NATO, that velocity is generally lower for equivalent bullet weight, and followed by this Springfield, which is shown in red line, and the bullet velocity is maximum for the 0.300 Winchester Magnum. So, it is highest. These are the basically velocity comparisons. Now, what are the different types of material choices? So, we have to decrease the weight, that is for sure, we have to decrease the weight. So, initially it was a glass composite was used, then aramid composites were used. Aramid has got higher density than the ultra high molecular weight polyethylene composites like Dyneema, Spectra. Okay. So, the for the same garment, if we produce from glass composite, that will be heavier, and aramid composite will be lighter than that, and ultra high molecular weight polyethylene if you use, then it will be the lightest because the density is lower. But the we have to, if we want to consider the cost also increases with the decrease in the weight. So, that we have to balance the material. Now, how the soft body armors evolved? First generation soft body armors were made of the silk. Okay. That is the from the silk, basically it is a lightweight, and silk has got a very specific strength is very high. So, first generation soft body armor was that developed from the multi layer silk fabric. This is by Japanese people, they used to use as a soft body armor. So, this type of body armors were used in First World War time, made from silk. So, they were very good in protecting against very low speed, like 120 meter per second. But they could not give any protection against the high speed. So, when the with the invention of the that high speed rifle, so that at say 180 meter per second they fell. So, that was the first generation body armor which was used by Japanese. Now, second generation body armors were basically it was used here where along with the jacket nylon flakes were used. So, some nylon chips flakes were used within the jacket. So, that is why it was called flake jacket. So, body armor were prepared from nylon flake. So, in a normal armor, so there nylon flakes were used. So, small pieces of flat nylon plates were used. Here the with this jacket, so here the nylon flakes were filled, that will actually absorb the bullet, that impact of the this any projectile. They are used in Second World War, where better than first generation, they can protect in a better way. Due to this nylon flakes, they were heavy and cumbersome. So, here we are putting some weight. Okay. They could not give any protection against most of the pistol or rifle. For heavy very high speed rifle, they could not give protection. And the third generation, when the para-aramid was developed in 1960s, the third generation body armor were prepared. This is the third generation body armor, where they give far better protection than silk or nylon flake body armor due to their high strength. However, for this type of para-aramid we need 20 to 30 layers of para-aramid fabrics for giving like suitable protection, required protection, and that makes the total structure inflexible, heavy. So, they again became heavy and inflexible, that was the problem. So, therefore, the challenge is for developing a new material that provides higher impact resistance while maintaining the assembly's weight at an acceptable limit. That was basic challenge for any this ballistic protective textiles, the soft body armor. With this keeping in mind all this requirement, so the scientists they started developing different types of fibers. The main problem, main pain point here is that to develop the material science is very important. So, the requirements were the better impact dissipation, that was the first requirement, better impact dissipation was requirement, then the weight reduction. So, we must use a material with a lower weight and flexibility. So, better impact resistance, lower weight and it should be flexible, that those are the basic requirements of modern age ballistic protective vest. So, we are talking about the soft body armor. So, the factors which affect the impact performance are fiber and fabric related parameters. So, we have to select the proper fiber and there are different types of fiber related parameters are there and also different types of fabric related parameters, that this we will discuss in detail. Next is the projectile related parameters, projectile shape, projectile mass. So, depending on this projectile related parameter we have to design our this clothing. Projectile velocity. Now, first let us discuss the fiber and fabric related factors. Now, if you see the fiber properties are there, the fibers which are used in the protective textiles, that ballistic protective textiles are basically the nowadays still it is used. In 1960s it was invented that pararamid, but still it is used with the improved version, that pararamid is used in the name Kevlar, which was developed by DuPont, and Teijing they market as a Tauron. Then polyethylenes are used initially, then PBO fibers were used, okay, which is known as Xylon, but Toyobo company they market as Xylon, and also nowadays very widely used that ultra high molecular weight polyethylene, like DSM they market as a Dyneema, okay. Also it is used available as a Spectra, Allied Signal they market, and also the inorganic fibers are also used, glass, ceramic carbon fiber, glass fiber. So, the different types of fibers are used. Now, the fiber properties. What are the different types of fiber properties? These are the different properties, like it should have high modulus. If we use a fiber with a low modulus, the problem would be that it will get stretched and it will not be able to transmit the energy to a larger area. So, it will deform easily. That is why we need a fiber with high modulus. Okay. Obviously, we need high tensile strength, otherwise it will get damaged or failure will occur at the lower force. So, high tensile strength is required as a requirement. Then it should have low density. So, density is very important, because we have to reduce the overall mass. Overall mass has to be reduced. So, low density is important, like ultra high molecular weight polyethylene. It is nowadays very widely used because of its low density. It should have low elongation. If a material is stretchable, then it will not be able to distribute or dissipate the energy to a larger area. So, the fibers we should use with a low elongation fibers. Fibers should have good resilience. So, what is resilience? After deformation, the fibers should come back in its original position. So, from the deformed position, that is good, it should have good resilience characteristics. It should be have low moisture retention capacity. It should not be highly absorbed, so hydrophilic. So, if the if we use some highly hydrophilic fiber like cotton, so if the it will absorb moisture and the weight will increase in one way. So, that it will the overall mass will increase, that is one aspect, but also if any textile material, if it absorbs the moisture, except cotton, most of the textile material their tensile strength reduces. So, that is why the materials should have low moisture retention or moisture absorption characteristics. It should be thermally stable, because when the projectile hits, due to the friction, high heat generates. So, that material should have highly thermally stable. So, thermal stability should be more, and it should have high LOI value, high limiting oxygen, because it will show that if in case of any flame, in case of any this fire, it should not get fire quickly, it should not catch fire quickly. And also the fibers, we should select fiber which are stable in extreme condition. So, these are the different requirements, because the bulletproof vest or any ballistic protective textile clothing we have to use in different conditions, extreme condition, maybe in extreme cold condition, maybe in extreme heat condition, like the soldiers in a Siachen area or very high altitude area where the temperature is sub-zero temperature, and if in the normal fibers they get brittle, they get damaged, normal commodity fiber. So, this stability at extreme condition should be there. Then coming the next important parameter, which is twist in the yarn. So, twist in a yarn is very important. So, because it is actually related with the breaking strength and breaking elongation, and also by changing, manipulating the twist, we can change the modulus. So, reduction in yarn strength at twist application. So, for any normally if we use in ballistic protective clothing, we use normally the filament yarn. Staple yarns are normally not used in this ballistic protective clothing. So, in filament yarn, multi-filament yarn, we can use here in multi-filament yarn. This is the twist level and strength. So, the pattern of the twist strength is like this. Initially there will be slight increase with a very low level of twist, because in multi-filament yarn when we apply twist at very low level of twist, there the when we need very low level of twist, because otherwise there will be the individual filaments will get spread out. So, that will create problem in the future further process also, that the individual filament can get damaged by abrasion. So, to hold this all the individual filaments, we have to apply a certain level of twist here. So, the twist is applied at the lower level. So, in that case little bit increase in strength will be there, but if we increase the twist, if we apply the higher and higher twist, what will happen? The individual that load on the multi-filament will not be shared by the fibers 100%. So, at the twist level 0, so when all the fibers are parallel to the axis, when the load is applied, the individual filaments are taking load. So, that ideally the load should be, the strength should be maximum there. But when we, and initial increase as I have mentioned, that is due to the binding action, that due to the inter fiber friction it is little bit increases, but after that as we increase the twist angle theta, the component of the load F, the fibers contribution will be say F cos theta, because fibers are aligned at theta degree towards the force applied on the axial direction. So, if we keep on increasing the theta, the twist angle, that means fibers contribution will keep on reducing, which will effectively reduce the yarn strength. So, that is why yarn strength reduces with the increase in twist level. So, we should not have the higher twist level. So, with the very low level of twist we require, because just to hold the individual filament, that is the idea. Breaking elongation increases with the increase in twist. So, if we increase the twist, what will happen? The fibers will have helix formation, and that is why the breaking elongation will increase. One is due to the extension of fiber, fiber will get extended, individual filament will get its extension, but at the same time due to the helical structure, when the load is applied, this helical structure gets straightened out, and that will add to the breaking elongation. So, breaking elongation also increases with the increase in the twist, and as the breaking elongation increases, so elongation increases, and this due to this helical structure, this is one structure, and if it is straight. So, if we draw, this is straight filament A and this is B, helical structure, twisted structure, and if we see the strain and stress behavior, and one will have so this will be A and B, because A the filament without any twist. So, this will actually take the load. So, from any high modulus filament, if we keep on twisting, the modulus of that filament, twisted filament will reduce. So, with the increase in twist, the modulus will reduce. Okay. So, the reduction in modulus with the increase in twist angle. So, as the twist angle increases, as I have already mentioned, so that will increase the reduce the modulus, and reduction rate is very high at the twist angle more than 5 degree. So, we should not go beyond this limit. So, we should keep the twist angle at very low level, although we need to apply twist as we have discussed to have the integrated structure. So, we will discuss other factors subsequently. So, till then, thank you.